Hey guys, today's lesson is how to find composite volume. So in the past, in our past videos and in class, we've been doing finding the volume of a shape. Now we're going to do the volume of a composite shape. Now this just means that you have a shape comprised of two or more shapes. So looking at this figure, this is kind of what it looks like in a 3D format. Looking at this figure here, we do not have a volume formula to find the volume of this whole thing. However, we do have volume formulas on how to calculate a hemisphere and a cylinder. So what we're going to be doing today is adding and subtracting volumes. So notice in this problem, I'm stacking a sphere on top of a cylinder to create this R2-D2 looking like shape. And what I'm going to do here is once I find the volume of them individually is I'm just going to combine them together through addition. So this kind of sums up everything we've been doing when it comes to volume by combining volumes together. So let's go ahead and get started. And the easiest way I know how to do this is to focus on one shape at a time. So I'm going to go ahead and focus on this top shape. Okay, I've got my top shape here. It is a cylinder. And I'm going to do all the math, or not a cylinder, oh my goodness, and that is a sphere. I'm going to do all the math for a sphere in here. All right, so let's go ahead and get started. My volume formula for a sphere is 4/3 pi radius cubed. And that's honestly just a formula you have to memorize. It's the more times you write it, the easier it is. There's no base in a hemisphere. It's just half of a sphere. So let's go ahead and calculate our radius. So looking at this picture from the center to the point on the sphere, my radius here is 7. So volume equals 4/3 pi, 7 cubed. So let's go ahead and focus on my exact volume. So volume equals, let's see, volume equals, I'm going to type it in exactly how I see it, but I'm not going to type pi. So I've got 4/3 times 7 to the third power. I get 457.3 repeating, so let's go ahead and just keep it as 457.3. Bring it down pi. Remember, pi's along for the ride. And this is a very crucial step here. This is a hemisphere, which is half of a sphere. So this formula, this is the volume of an entire sphere. I don't want the whole sphere. I only need half of it. So to show that this is half of the volume, I'm just going to divide my answer by 2. And I'm going to get volume equals, so I'm going to go right here, keep it in my calculator, just do divided by 2, and I get 228.7. So 228.7, remember pi just comes along, and this is centimeters to the third. So that is now the first part. We found the volume of our hemisphere. Next, we have to focus on the bottom, which is a cylinder. So now I'm going to do the volume formula for this shape. Okay, and this shape is a cylinder. So I'm going to do all my volume work just to make it easy for us. All our volume work inside of this box. Organization is key to make difficult concepts easy. So if you can kind of block it off and do, okay, here's this info, it makes it a little bit easier. So this is a cylinder. My generic volume formula for anything with 2 bases is just area of the base times height. Let's make that more specific for the type of shape that we have. So this shape is a cylinder, which means my base shape is a circle. So when I switch out area of the base, that capital B, I'm going to put the area formula for my base shape, and my base shape is a circle. So I'm going to change this to pi r squared and bring down height. Let's go ahead and substitute. So pi. If I'm trying to calculate the radius of my cylinder, this radius is the same as it was up here. So it was 7 here. It's going to stay 7. So my radius is going to stay 7. And my height this time is how far away the 2 circles are. So looking at my picture, I have my 2 circles here and here. So that height, how far away base 1 is from base 2, is 11. So I'm going to bring everything down just so it lines up. I'm just going to write it down here. I'm going to go ahead and type it into my calculator. I'm going to do 7 squared times 11 to get 539. So 539, pi is along for the ride, centimeters cubed. Now these volumes are stacked on top of one another, which just means that I am going to be adding my volumes together. I want the volume of the hemisphere plus the volume of the cylinder to give me my total volume of this weird shape. So what that means is I'm going to be adding my volumes together. So I have 228.7 plus 539 pi. So what I'm going to do in my calculator is combine like terms. 228.7 plus 539. I get 767.7. So my volume is 767.7 pi centimeters cubed. Or let's go ahead and round. I'm just going to go ahead and do times pi. And we get 2,411, rounding this up to 12. So 2,412 to the nearest cubic centimeter. All right, let's try the next one. Here is our next shape. This next shape looks like a little cylinder with a cone on top. Okay, cylinder with a cone on top. So this looks like this. Okay, so here you go. Kind of matches what that figure looks like. Again, we're going to find the volume of the cone first, then the volume of the cylinder. So what we're going to go ahead and do is find this volume first. And it really doesn't matter. You can do any volume you want, as long as you are just finding the volume. Okay, so let's go ahead and try this one. So I'm going to do the volume of this cone first, and it really doesn't matter which one you do first. I'm just choosing cone. Okay, I'm just going to choose the cone. So in a cone, I have one base, so I should be putting 1/3 in front of my volume. So 1/3 area of the base times height. Let's go ahead and sub 1/3. My area formula, since this is a cone, my base shape is a circle, so I'm going to replace my area of the base with pi r squared, bring down height. So volume equals 1/3 pi. My radius of my cone, I'm going to have to use the radius of my cylinder. So this radius is 1. That means it's going to stay 1 as it goes up into this problem. 1 squared. My height of my cone is 3. So let's go ahead and find our exact volume of our cone. So parenthesis 1/3 times 1 squared times 3 gives me a volume of 1 meter cubed. And we're going to make sure to bring pi down. Now if you just want to leave it as pi meters cubed, that's fine. I'm going to put 1 in front of it just so we know there's a 1 there. Our next shape is this shape, which is a cylinder. So we're going to find the volume of our cylinder. Okay. So looking at this cylinder, this shape has 2 bases. So that means I'm going to leave the 1/3 off. I'm just going to do volume equals area of the base times height. It's only 1/3 if you have 1 base. 1 base, 1/3, 2 bases, you just area of the base times height. All right, so this is a cylinder, so my base shape is a circle. So when I do area of the base, I'm going to go ahead and write pi r squared and bring down height. Okay, let's go ahead and plug in all our stuff. So pi, my radius of my cylinder is 1 squared times my height of my cylinder is 12. So remember, height is not how tall the shape is. Height is how far away base 1 is from base 2. So my circle bases are here and here, which means height is a vertical distance. Let's go ahead. 1 squared times 12 is just 12. 1 squared is 1. 1 times 12 is 12. Pi is along for the ride, meters cubed. So what we've gone ahead and done for this problem is now we've found the volume of our cone, which is here. We found the volume of our cylinder, which is here. And to make this shape on the left, we just add our volumes together to get this big shape. So what I'm going to do to help me remember is I'm going to put a big plus sign right here. I'm going to put a plus sign right here. I'm adding my volumes together because I'm just stacking shapes on top of one another. Okay. So when I add my volumes, 1 plus 12 is 13 pi meters cubed. Or if I want to go ahead and find my rounded volume, I'm going to just do 13 pi, not e, that's a different thing from algebra 2. So 13 pi, rounding to the nearest cubic meter. This 8 bumps this up to 41. So 41 meters cubed. So on these first two examples, what we were doing was adding volumes together. On this last one, we're removing a volume. So we have this tiny hole that's been like drilled out of our cylinder. So the way we're going to do this problem is through subtraction because I'm removing a piece of my value. So what I've got here, I've got my big outer cylinder. I'm going to find that volume first. So 2 bases, it's just area of the base times height. It's a cylinder, so we're still using pi r squared times h. This is where it gets tricky. Now looking at this large cylinder, my complete radius is 6 plus 3, which is 9. I have to make sure that I'm incorporating the 6 plus the additional 3 inches for the thickness of this tube, kind of. So my radius for my big cylinder is 9, and my height is 17. So let's go ahead and type that in. Remember, we're going to keep it exact volume just to make it a little easier on ourselves when we simplify. 9 squared times 17 gives us 1,377. So 1,377 pi inches cubed. And now we're going to find the volume of this inside piece. This is the part we're removing. It's like a tube. I'm removing this cylinder. So I'm going to do my volume here. It is still a cylinder with 2 bases, so we're still going to use area of the base times height. It's a cylinder, so I'm going to replace it with pi r squared times height. On this problem, my radius is just 6 because it stops when it gets here. So 6 inches is my radius, and my height is still 17. So when we type this into our calculator, I'm going to do 6 squared times 17. For an exact volume of 612, bring down pi inches cubed. Now what we're trying to do here is we are actually removing this volume. So I'm like drilling a hole out of my cylinder. So if I'm removing volume, I subtract bigger volume minus smaller volume. So for my volume, I'm going to do 1,377 minus 612, 765. Pi inches cubed, or I'm going to multiply that answer by pi, rounding to the nearest whole number, cubic inch, 2,403 inches cubed. So the important thing to remember when working through these volume formulas, if you are combining volumes together, like stacking volumes on top of one another, you add the volumes. If you're removing a volume, so I'm removing this piece from my cylinder, you subtract. So combining or stacking volumes, you add. When you're removing volumes, you subtract them. But remember, you know how to do the volume formulas for all of these shapes. You just have to break them down into shapes you understand. So that is the trickiest part, but if you stay organized and find the volumes individually, it will be easier to add and subtract them.